Welcome. So what I'm going to do is show you how to solve this quadratic equation by using our AC method. And the important thing when looking at this is obviously when we want to solve a quadratic equation, we always want to set our output value equal to 0 because we're going to solve the values of x when this equation is true for the values of x that make this that are equal to 0. So the first thing we always do is we notice that our value of a is not 1. So we can't apply any factoring techniques we've done before. And we always want to see, can we factor out this value? But I notice I cannot factor out a 15 out of the rest of these terms, so I'm going to have to leave it as is. So what I'm going to show you in this method is we're going to use the box method. And when applying the box method, we look at this expression, right, as an area. And what we're going to want to do is we're going to want to be able to figure out what two values multiply to give us that area. And that's particularly what we're doing when factoring. We're trying to rewrite an expression as a product of its factors. So if we're given an area, we want to find what are the side lengths that we have to multiply to give us that area. So we need a little help, and we need a couple of different rules to use with this. But when using the box method, we're given the area, and we have 15x squared, and then we have negative 2. But what we need to determine is what is going to fill in these two boxes. So therefore, we have to go back to our x. And again, since the absolute value of a is greater than 1, we're going to have up top a times c and b on the bottom. Well, a times c is going to be 15 times negative 2, which is a negative 30. And then our c is going to be 7. All right, so now I need to determine what two values multiply to give me negative 30, but then add to give me 7. And remember, when we talked about like our tips and tricks, one of these numbers, if I'm multiplying to get a negative number, one of my factors has to be negative. And then since I'm adding to give a positive number, the largest of the factors has to be positive. So when I go ahead and write these out, let's do negative 30. I know that the 30, or if I do 30 times 1, I know the 30 has to be positive because the larger of the two numbers is positive. However, 30 plus negative 1 is not going to give me a positive 7. So let's keep on going down the list. How about 15 times negative 2? Not going to cut it. How about let's do 10 times negative 3. Yes. And you can see that 6 times negative 5, that does not add to 7. 10 and negative 3 does work. So therefore, I can say, all right, here's my 10, here's my negative 3. However, when we write these in here, we need to make sure that this box represents this expression. So 10 plus negative 3 gives me 7. It does not give me 7x. So I need to make sure I rewrite these as 10x and negative 3x. Now this box represents this expression. They're the exact same values, just written in different forms. So now that I have this as a box, what I need to do is now find the side lengths of the box. What are the values that multiply to give me that area? And those are going to be our factors. So we look at 15. We say, all right, there's a lot of different ways we could write 15x squared, right? We could have 15x times x. We could do 3x times 5x, and a lot of different versions. But what we want to do when we're trying to figure this out, I'm not going to use 15 because whatever side length I pick, that value has to divide into both of these boxes, right, evenly. Otherwise, you're dealing with fractions, and it's going to make the problem a lot more difficult. So I can't use 15 and x. I can't use 15x and 15x. Well, 15 does divide into 15 here, but 15 does not divide evenly into negative 3. And I can't use 15 up here and x down there because 15 does divide into 15x here, but 15 does not evenly divide into 10x. So now let's go back to the drawing board. What about if I use 5x times 3x? Well, again, we have a problem because 3, yes, they both divide into 15, but 3 doesn't divide into 10, and 5 doesn't divide into negative 3. However, when I switch these around, I now have values that 3x, yes, divides into 15x by 5x, and 3x divides into negative 3x by negative 1. 5x divides into 10x by 2. And now I've created my factors. And notice that 2 times negative 1 multiplies to give me negative 2. So now I've found my side lengths, which are what I call my factors. So I write them out in factored form. So therefore, now I have recreated my quadratic in general form to now intercept form. And when I have it as a product of two factors equal to 0, I can use my zero product property. So therefore, I have 5x minus 1 equals 0, and 3x plus 2 equals 0. Add the 1. 5x equals 1. Divide by 5. Divide by 5. X equals 1/5. And over here, I have 3x equals negative 2. Divide by 3, x equals negative 2/3. And there you go, ladies and gentlemen. Those are your solutions to your quadratic. Thanks.